In section 2.8, we are going to be talking about, let me get rid of this thing, function operations. And composition. All this means is we're going to be doing a combination of functions. Instead of just looking at one combination, instead of just looking at one function, we're actually going to be looking at a combination of functions. So let's take a look. First, let's get started by just reviewing notation. And let's use the function f of x and g of x, two totally different functions. If you ever see notation that says f plus g of x, and we'll look at this with examples, that means you just take the function f of x and you add g of x to it. You might have to get a common denominator if there's a fraction, which there probably will be on like the exam or the final, but I'm sure you can handle that. We've done a lot of work with fractions so far. And f minus g of x would be f of x minus g of x. What if we had f times g of x? Sometimes we could use like a closed dot in here. If we see f times g of x, of course that just means we take f of x and we just multiply it by g of x. If we take f over g of x, that means we take f of x and divide it by g of x. Now if they're fractions, it might require multiplying by the reciprocal. And then the last thing is if we see f with an open circle g of x, please don't ever say fog. That's like really bad. This just means you take f of x, but inside of f of x, instead of the x there, we're going to put g of x. And we'll see examples with that. All right, so let's get started. Perform the following and state the domain Okay, so let's get started. And in this example, f of x is going to be x squared minus 1, and g of x is going to be 2x plus 1. And h of x is actually going to be a graph. We've done examples like this before, where the graph is 1/2 x plus 2. So we'll go up to 2, go up 1 over 2, and that's what the graph will look like. Okay, so for our first example, let's figure out what f plus g of 1 is. Now what this means, this doesn't mean we're multiplying by 1, this means instead of this being an x, right, like we have in the notes, we're going to put 1 in for all those x's. So we're going to have f of 1 plus g of 1. F of 1 would be 1 squared minus 1, I'm using the function f of x, plus g of 1. 2 times 1 plus 1. Let's see what this is. This is going to be 1 minus 1 plus 2 plus 1 is 3. So there's no real domain to talk about here. The answer is just 3. We'll talk about domain if there's an x in it. For our next example, what about f of g of negative 2? So it looks like this. Closed circle means we multiply, so we're going to multiply f of negative 2 times g of negative 2. Well, f of negative 2 is negative 2 squared minus 1. Whatever that answer is, we're going to multiply it with g of negative 2. 2 times negative 2 plus 1. So it'd be 4 minus 1 is 3 times negative 4 plus 1 is negative 3. So the answer for this would be negative 9. I'll do C on the side here just so I can see my functions. For C, what if we had f minus g of x? Well, that just means f of x minus g of x. So f of x was x squared minus 1 minus 2x plus 1. Now just remember, we're subtracting the whole function, right? Not just the 2x. So this is just x squared minus 1 minus 2x minus 1. Gives us x squared minus 2x minus 2. The domain for this would be infinite, right? It's clearly a quadratic. We could plug any number into this. There's no denominator and no radical. So our domain would be negative infinity to positive infinity. What if we had f over g of x? Well, that just means f of x divided by g of x, which is x squared minus 1 over 2x plus 1. So x squared plus minus 1 does factor. It would be x plus 1 times x minus 1, but that wouldn't cancel out with the bottom. So what would be our domain? Well, I do see a denominator, and if you remember back to our lesson about domain restrictions, your denominator can equal 0. So 2x plus 1 can equal 0, and that would happen when x is negative 1/2. So we could use any number up to negative 1/2, but we just can't use negative 1/2. All right, and let's go to E. What if I asked you what's f of g of negative 2? F of x is x squared minus 1, and g of x was 2x plus 1. Okay, so what this means is, let's start from the inside out. What's g of negative 2? Well, put negative 2 into g, right? We know how to do that. And we get 2 times negative 2 plus 1. Negative 4 plus 1 is negative 3. So that inside piece is negative 3. Now what we're going to do is we're going to plug that into f. F of negative 3 would be negative 3 squared minus 1, or 9 minus 1, which is 8. Lastly, let's do letter f. And letter f says let's figure out f of g of x. Well, first figure out the inside. The inside g of x was 2x plus 1. And what happens when we plug 2x plus 1 in for the x in f? So instead of saying x squared minus 1, we're plugging in 2x plus 1 there. Okay, oh gosh, please don't do this. All right, we have to FOIL that out. So this would be 2x plus 1 times 2x plus 1, which would be 4x squared plus 2x plus 1 minus 1, which is 4x squared plus 4x. That would be our answer. So I told you before, I hope I didn't scare you, but there are going to be some fractions that you need to know how to work with. So let's take a look at some more complicated ones. This is the level that you could expect on an exam. So what if I told you that f of x was 6 over x minus 3, and g of x was 1 over x. Okay, so let's do 3 of these. First, let's figure out what f of g of 2 is. Remember, this is notation for f of g of 2. The way that we do this is we figure out the inside first. So what's g of 2? Well, if you plug 2 in for x, I mean, that's easy. That's 1/2. So now f of 1/2 means we plug 1/2 in for x. So that's going to be 6 over 1/2 minus 3. And now we have some simplifying to do. Well, 1/2 is the same. Well, let's get a common denominator. So 3 is the same thing as 6 over 2. So we're going to have 6 divided by 1 over 2 minus 6 over 2 is negative 5 over 2. And when you're dividing by a fraction, that's the same thing as multiplying by the reciprocal. And that would be the answer for this. What if we had instead, let's say f of g of x with an open circle? Well, just like before, there was this, not a big deal. So we know we figure out the inside first. G of x is just 1 over x. So we're going to have 6 over, instead of x, we have 1 over x minus 3. Okay, well, let's do the same thing we did before, where we get a common denominator. And this turns into 6 divided by 1 minus 3x all over x. I just combine these two fractions. 1 over x minus 3x over x is 1 minus 3x all over x. Well, just like before, when you have division, we could just change that to multiplication. And we get 6x over 1 minus 3x. Now let's just stop to figure out the domain quickly. We do have a denominator, so the denominator can't be 0. So we get 1 minus 3x. Let's make it equal to 0 so we could figure out what it can't be. And x would be 1/3. Also, one other thing, I'm looking at the problem. Do we see denominators anywhere else? So in our final answer, we see it. But also look over here, right? Remember, we do have 1 over x that we get a common denominator and we work with. So we can't have 1 over x equal to 0 either. Or we can't just have x equal to 0 also. So how do we write this domain? We can't use 0 because that makes this part a problem. We can't use 1/3, that makes that part a problem. So on our number line, looks like we could do from negative infinity to 0 in union with from 0 to 1/3, and then from 1/3 on. That would be our domain. We'll do one more of these. What if we had g of f of x? Okay, well, f of x, we'll figure out the inside first. Just kind of scrolling back up here. F of x was 6 over x minus 3. And g of x, if you remember, was 1 over x. So instead of 1 over x, we're going to put 6 over x minus 3. So this is just 1 divided by 6 over x minus 3, which is the same thing as 1 times x minus 3 over 6, which is the same thing as x minus 3 over 6. That's our answer. Now let's take a look at our domain. Looking at the problem, well, we can't have x minus 3 equal to 0 because that's a denominator. So x can't be 3. All right, same thing here, same thing here. All right, it looks like that's the only time that shows up. So our domain would be any number, just not 3. So we'll go up to 3, we'll go past 3, but we won't include 3. All right, and there's one last thing I wanted to talk about. It's called the difference quotient. Now you'll learn more about this in calculus. This actually comes up when you talk about a derivative. And if you've ever heard that word before, derivative just means a fancy word for slope. It's the slope of a tangent line at a point. So if we had a line like this, maybe y is equal to 2x plus 3, the slope would be 2, right? But what about if you had a graph like this? Well, the slope of a tangent line would be all different. This would have a negative slope, this would have a negative slope, this would have a slope of 0, this would have a positive slope, this would have a positive slope. But if that's the graph y is equal to x squared plus 2, there is a way we could figure out the slope of the graph at a certain point. Take this point right here. That point is maybe, whatever you want it to be. What we could do to figure out that slope at that exact point is we could estimate it by taking the slope of 2 points. So watch, ready? If I had a point right here and right here, if I found that slope, that would give us the slope pretty much at that point. It's a good approximation. We'll give this value x. So this value would be f of x. And a little bit further on, I don't know how much further, we'll just say a little bit further, x plus h, where h is just like a little bit more. Well, if we want to find the y value at that point, that would be f of x plus h. So if we want to find the slope of these 2 points, the first point has the coordinates x comma f of x. The second point has the coordinates x plus h comma f of x plus h. Then the slope of the line that goes through those right here would be a difference in the y values. Subtract these two. Over subtract the x values, which simplifies just to what's called the difference quotient. So going forward, the difference quotient will be provided for you, but that's where it comes from. It comes from taking the point, the slope of a line that's tangent to a graph at a point. And it's 3 functions. First thing we do is figure out f of x plus h. That's one thing to do. Then we subtract f of x. That's a second thing to do. And then we divide the whole thing by h. That's the third thing that we do. So let's take a look at a couple examples. What if we had 2x, let's say f of x was equal to 2x plus 3. Let's find our 3 parts. Maybe I'll use different colors so you can see exactly like what's happening here. I use purple for the first part, maybe orange for the second part. And then when we go to divide by h, we could use blue. All right, so let's do this. So what's f of x plus h? We're going to plug x plus h in for x right here. So 2 x plus h plus 3 minus f of x Well, I told you what f of x is, right? F of x, we don't really have to do anything. But we're not going to write minus 2x plus 3 because we have to subtract the whole f of x. And then we divide that whole thing by h. So let's clean it up, and that would be our difference quotient. So we get 2x plus 2h plus 3 minus 2x minus 3 all over h. 2x's cancel, the 3's cancel, and 2h over h. Generally, how these problems usually work is you're going to have a lot of cancellations. And one thing I would recommend you do is sometimes you could factor it out, but I mean you could see you're dividing by h here, so the difference quotient would just be 2. Let's try something else. Maybe make this one a little bit more challenging. What if we said f of x was, and by the way, look at this, right? What's the slope of this line? 2. 2. So you could see that's exactly what we did over here when I was explaining. We're really just finding the slope. But now let's do a quadratic. What if I told you f of x was 2x squared minus 3x? First thing we're going to do is find f of x plus h. So if I plug in x plus h for all the x's, so that's f of x plus h. Now I'm going to subtract f of x. But remember, we're subtracting the whole thing, so we need to use parentheses. Then I'm going to divide the whole thing by h. Okay, so this will be fun. I'm going to do 2 times x plus h times x plus h minus 3x minus 3h minus 3x minus 2x squared plus 3x all over h. Well, I could cancel these off first, right? This is going to be 2 times x squared plus xh plus xh is plus 2xh plus h squared minus 3h minus 3x minus 2x squared over h. Let's distribute and try to clean it up a little bit. This is going to be 2x squared plus 4xh plus 2h squared minus 3h minus 3x minus 2x squared all over h. Okay, so these cancel. What else? I think that might be it. Let me just double check my math, make sure I didn't miss anything. There's 3x plus h. Oh, I actually had an extra 3x here. Remember, it was just minus 3x, so I put the x plus h in already. So I didn't have to write it again. I'm sorry about that. So this 3x doesn't exist. All right. Now let's finish it up. So we have 2h squared plus 4xh minus 3h over h. And we could actually factor out an h. Remember how I mentioned that before? Sometimes we factor to finish up. And these would cancel. So we get 2h plus 4x minus 3. That would be our answer.